Assalamualaikum to Prof. Madya Dr. Abdullah. My name is Ummi Zulaikha binti Zuliskanda with matric number 71855 and we are from group 37. Today, I would like to present about our product selection for manufacturing process is piston. First, I will present about what is manufacturing process, product description, flow process, defect of the manufacturing process, design consideration and analyze the manufacturing process. This is introduction of manufacturing process. Manufacturing process are made by hand and have three elements that the main is design, selecting material and manufacturing process. This process is from raw material to product such as piston. So, today, me and Faqrul Radzi would like to present about casting process, joining process, metal and non-metal forming process of a piston. Product description. The first picture is a raw material for the piston and the piston are used aluminum solid rod. The process that involve to make a piston is casting process, joining process, metal and non-metal forming process. The second picture shows the finished product of car piston that go through all the manufacturing process. I will present part of casting process and joining process. For this part, I will present about flow process of casting process. For this process, we are choose sand casting process to make a connecting rod. Connecting rod is a part of the piston and it was joined between the piston head and rod cap. We choose sand casting process because it was the easier process rather than another casting process. For this casting process has various tools such as hand wheel, shovel, rammers and screw pin. The first step of sand casting is place mold pattern to mold that have filled with a sand. Then we use a rammer to remove the excess sand from the sandbox. Then step 2 is construct gating system of the sand casting. This purpose to guide the molten metal from the ladle to the casting cavity and fulfilling into the mold of the connecting rod. Third step is the pattern of the connecting rod are removed from the sandbox. Two boxes are opened and the pattern is removed with help of the draw spike. Why this pattern are removed? Because inside the sand it already has the shape of the connecting rod. Fourth step is pouring molten metal into the cavity of the mold. This step uses a screw pin to make a hole in the sand to make it easier to pour molten metals. For this molten metal, we use aluminum alloy with melting temperature around 660 degrees Celsius. The next step is metal cooling down. We must wait for the metal to cool down after we pour the molten cast aluminum alloy into the mold of the connecting rod. This part will take time based on the materials that we use. Last step is remove the metal casting from the sand mold. After the metal is cooled down, we can remove it from the sand mold to see the finishing of the product. Then, the connecting rod will be cleaned by a fiber brush and use a grinding to remove the excess molten metal on the connecting rod. This is the picture of process of the sand casting like what I have explained before. I would like to share with Prof some video from the YouTube that we get in the next slide. This is flow process for the joining process. This process, we choose the mechanical join, or other name is fastener joining process. Mechanical join is widely used for the part of joining of two or more metals part in temporarily or permanently. For our product, we are used temporarily joining that involve drilling, bolting, and pin that we use wrist pin or gouge pin. The first step is drilling. We need to drill a hole in both sides of the connecting rod to join it with the bolt and nut. Firstly, we need to make a center drilling for the big end bolts by using size 10 mm of the drill tools. After that, we drilling both sides of the bolts holes using the size 3 mm. The second step is bolting and pin join. For the bolting part, we are use hurricane bolt to link the connecting rod with rod cap, and these bolts are strong rather than other bolts for joining this product. For the pin part, we use the wrist pin, or other name gouge pin, that connect the piston head to the connecting rod. This pin prevents the cylinder wall from scoring. Next slide. I will present about defect in sand casting and joining process. Defect in sand casting is unfilled section when finishing occur. This is caused by materials are not really molten with the specification of the temperature for the some of the materials. The defect can reduce is make sure the molten cast aluminum alloys is perfect molten with the temperature in 660 degrees Celsius, and the materials is enough to produce a medium or big product like a connecting rod. The second defect is porosity. Porosity is caused by the temperature of the melt is too high than 660 degrees Celsius for aluminum alloy, and the permeability of sand is poor with the high moisture. The porosity can reduce by control the temperature of the molten metals being poured into the mold sand and reducing the moisture of the sand. Then, surface projections not smooth is a part of defect in sand casting. This causes by the interior sand mold erosion because of sand mold is not dense and maybe had something inside the sand mold. This defect we can reduce is the sand mold are really dense with the product mold, and the sand must be used hand wheel to separate between the sand and other things such as a small stone. This is the example for the defect in sand casting. This is defect from the joining process. The defect of joining process is stress and strain in connecting rod with rod cap and the piston head in bolting and pin join. This defect we can minimize it by ensuring sufficient thread commitment in the construction of the fastener and use the specification of the bolts and pin that's suitable with the hole of the connecting rod, such as for alloy the proof stress we use head 130 megapascal and tensile stress is 1030 megapascal. It can be higher from the value of the proof stress and tensile stress. This can be our product is broken. Design consideration for sand casting process. It have 4 for the design consideration that we need to take note. First is drawing of connecting rod, such as our product is connecting rod. The draft of the drawing should have a size and shape of the product that we need to produce. Second, tolerance level. This part is important to produce some products such as we use aluminum alloy to produce the connecting rod with the tolerance level for these materials is more or less 0.5 mm. Third, alloy selection. For our product such as we choose aluminum alloy for our connecting rods. This consideration should have a strength of the materials, durability, toughness of the materials, and the corrosion resistance for our materials when we finish produce the product. Lastly is inspection of the surface. This part makes sure our product not have more defects or error on it. The design consideration of joining process is Modularity for product design such as our product is piston and the higher quality components. This is continued from the before slide. For the modularity, uh, for product design is the amount of different function is increasing, so the automatic assembly device complete reduce the system reliability. For the design consideration in high quality component is to join the connecting rod with rod cap, we use the hurricane bolt better than other bolt and it very strong joint of two parts of the product. And when we use the low quality components, the joint of two parts will be addition to each other and make the resulting product in downtime. Last section for my part about custom engineering process is analyze the, the both of the process. For the casting process, our product can be optimized with the low tooling cost of the process and the versatile shape with the weight of the product. This is because the tools of the casting process can find at any hardware store such as hand wheel, shovel, sand that we use for the mold and molten materials such as aluminum alloy. For the versatile shape and weight is we can design or draw for our product such as gear, connecting rods and other components. The joining process can be optimized by a low cost production of the product such as the production is performed by manually or automatically by a robots to join two or more the components part like bolting joint on connecting rod with the rod cap. This can help the manufacturing save their cost and their time to produce the part used by the bolting joint, welding process, and soldering. So that's it for my part of casting and joining process. I will give the next part about metal and non-metal forming process to the next presenter is Muhammad Faqrul Radzi. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Faqrul Radzi bin Muhammad Helmi with matrix number 72408. First of all, I would like to thank Zulaikha for presenting the first part of our project, which is on the casting process and joining process. In the second part of the presentations, I am going to present to you about the metal and non-metal forming process. Clearly, the differences between these two processes is the material used in the process. Usually, in a metal forming process, we are using a materials that has a characteristic of metal. For example, aluminum and steel. For a non-metal forming process, we are using plastic. Metal forming process. Our group has selected to use a fogging process, which is a process under metal forming process in the making of piston. Here we can see that there are several parts in a piston. A piston consists of piston head or crown, top compression ring, oil scraper ring, oil control ring or oil ring, piston pin and piston skirt. In the next slide, I will explain to you all of the piston parts. Parts of a piston. The first one is piston crown. Piston crown is top surface of the piston which is subjected to tremendous forces and heat during normal engine operation. Next, a compression ring. A compression ring is located at the top side of the piston nearer the combustion chamber, and it prevents the combustion gases from leakage. After that, oil scraper rings. It is located in the middle of compression rings and the oil rings. The function of oil scraper rings is it works in sealing the combustion chamber. Lastly, piston skirt. It is located closest to the crankshaft that helps align the piston as it is moved in the cylinder bore. We have come to the interesting part of this presentation. As you guys can see, here is the piston manufacturing process. In the first process, which is the material selection, we are required to choose a material that is suitable to create a piston. For our group, we have selected a piston that is made from aluminum alloy. The reason we choose aluminum is that it is a lightweight, rust-proof, and easy to cut. After we have selected a material that we are going to use, then we need to cut it into a small pieces or slugs using a saw. In the punch process, we are applying a deep drawing process to shape the slug. A punch press and die are preheated while the slug moves through an oven and heating it to 4 to 6 degrees Celsius as the punch press. The slug is then removed from the oven and placed into the punch. The oven process. After fogging cool down, the slug goes through an oven twice more. The first one is at higher temperature, which is to strengthen the metal. And for the second time, they are put in low temperature to stabilize it. In the respin holes and oil control holes process, a large hole is drilled through both sides of the piston, and oil control holes are drilled along the slug. After that, by using a lathe machine, 3 ring grooves are created. After ring grooves are created, a milling machine is used to shave up to a couple of centimeters of each side of the piston where the large holes were drilled for the respin insertion. After that, a piston is grinded from its head to give the crown the shape required according to the design. Lastly, before the piston is ready to use, they need to go through finishing process. For a non-metal forming process, we have selected to create a plastic piston ring. The process is the same in the making of connecting rod. It's just the difference is we use a liquid plastic to create the piston ring. Usually, a plastic piston ring is suitable for a compressor piston. For a car piston, we need to use a piston ring that is made from steel or iron. Here is the defects that is caused by metal forming process and the prevention. For the first one, there are variations in the size of the piston due to the temperature of piston is not maintained accurately during process. To prevent it, a coolant should be changed and maintained at a constant temperature. Next, tool grinding leads to deep cut or improper surface finishing. To prevent it, tool has to be grinded or changed whenever it is necessary. Lastly, the speed of machine is not constant, which causes improper machining on the surface of piston. To avoid this, the operator should follow the SOPs strictly and have some training. This is the presentations of the defect and preventions on the non-metal forming process. The first one is piston rings may break due to some finishing required in the casting process of non-metal forming process. The solution that we can take is change the plastic material to steel or silicon cast iron. After that, a piston ring might unbalance because of the diameter and size is not constant. To prevent this, make sure the properties of material is known and take note on the tensile strength and plastic deformations of the material. Next, we are going to talk about the design considerations for metal and non-metal forming process. In the metal forming process, there are two considerations that we can make. The first one is accurate positioning of the slugs in the die cavity. This is to get a constant thickness of the piston so that the piston does not have any defects due to the unbalance. After that, a material use. The selection of material is very important in order to create the piston. The properties of materials should be considered, such as the melting point and ultimate tensile strength. For a non-metal forming process, the first one is section size and shapes should be selected properly. This is because a plastic has much lower stiffness and strength as compared to metals. After that, for the thickness, large variation in the thickness should be avoided to achieve proper shape generation. These are the considerations that we should take note so that a good quality product can be produced. Lastly, we are going to talk about the optimizations on the metal and non-metal forming process. The first one is a planning process. This process is very important for us to select a suitable material in the manufacturing process. By doing a planning process, we have an advantage to save costs. After that, we can have a scheduled process. This is to minimize production times and to minimize costs. The second point is especially for the non-metal forming process. This is because the process we use in here is sand casting. Usually, a sand casting process will take much time as compared to the other process. So, by scheduled process, we can minimize time and improve the number of production. In the next slide, we are going to watch a video on the piston manufacturing process.
10,000 horsepower, 0 to 200 miles per hour in 2.2 seconds, 11.2 gallons of fuel consumed per second. A top fuel dragster is one of the fastest accelerating vehicles on Earth. How does it achieve such amazing speeds? It converts all of the energy in the fuel into mechanical energy through combustion. The part of the engine responsible for converting this energy is called the piston. A piston starts its life as a raw ingot of aluminum. It is cut by a circulating saw into smaller pieces, about 7 centimeters long. This ingot is then preheated to 420 degrees Celsius and placed in a forging machine. This machine deforms the ingot into a shape that begins to resemble a piston. Next, the pistons go into an oven for a stress-relieving heat treatment before being placed on a lathe. The lathe machines the top and sides of the piston. Oil holes are drilled in the side skirts. Then, it goes back into a lathe where the piston ring birds are machined. Next, the piston pinholes are bored, and the piston gets reliefs milled into the side skirts. Lastly, the head of the piston is machined the correct shape to match the combustion chamber. This is done on a multi-axis CNC mill. Once completed, multiple pistons can work together to do some amazing things.
That is all from us. We would like to thank everyone for watching our video. Hopefully everyone is doing good and have a nice day. Thank you.